Hey everybody, so in this video we're going to start talking about 7.3. I have a feeling there's going to be quite a few videos on this section, but we're going to start with part 1, which is Introduction to Logarithms. Okay, so the first thing I want to do is just give some background about why we're interested in these, and then we'll talk about what they really are. Okay, so in the last section we talked about inverse functions, okay, and we really talked about pairs of functions that are opposites. Okay, so if we think about it, our pairs were like plus and minus, right? Multiply and divide. Okay, these are pairs of opposite functions. Then we had like powers like squared and roots, okay? Or even bigger powers like x to the fourth and the fourth root, okay? These were examples of opposites, okay? And then in 7.1, we had talked about functions that looked like b to the x. Okay, so the question is, what's the opposite of this function? Okay, and that's where we really get into what a logarithm is. So let's look at the definition. Okay, so the definition of log base b of x, okay, also we would say this is the logarithm base b. Okay, so this is what this is called. So if we have logarithm base b of x, this is an exponent, first of all. And specifically, it's the exponent that you would raise b to in order to get the answer x. Okay? Right? So when we're looking at this, we're thinking b to what power is equal to x? Okay? So let's look at some examples. Okay, and we're asking to evaluate without a calculator. Okay, so let's look at one example. Okay. All right, so when we're looking at this question, okay, here's our base b. It's called a base in the logarithm, and it's also called the base in the exponent, okay? So we're saying 3 to what power is equal to 81? Okay, so you know that 3 to the fourth power is 81. So that means that this is equal to 4. Okay, so again, this number is the exponent. So 3 to the fourth power is equal to 81. Okay, let's look at another example. Okay, so this question is 10 to what power equals 10,000? Okay, so we know that powers of 10 add a 0, so we're going to have 1, 2, 3, 4, the fourth power, right? So 10 to the fourth power equals 10,000. Okay, so now that we've seen the basics of this definition, let's go ahead and do some more complicated examples. Okay, so the first thing we're going to do here, okay, is look at this example. All right, so we're saying what power of 2 is equal to 2? Okay, so we really have to remember our rules about exponents. What exponent just gives the base back? And the answer is 1, right? 2 to the first power is equal to 2. Okay. All right. So I'm going to list some other examples. Okay, and I want you guys to go ahead right now and pause the video and get your own answers for these questions, okay? So remember what you're asking yourself. What power of this base, okay, is equal to this number? Okay, so go ahead, pause it now, and write down your own answers. Okay. Now that you have your answers for yourself, let's go ahead and look at what the answers to this would be, okay? So we're saying 2 to what power is equal to 1? Okay, so we have to remember our exponent rules again. And we know that anything to the 0 power is 1. So this is going to be 0. Okay. For this question, we're asking ourselves 2 to what power equals 2 to the x? Okay, well, if you want the exponent to be x, okay, right, you're just trying to match these up. So what do you need to put in the exponent to get 2 to the x? Well, you need 2, or I'm sorry, you need x, okay? Here we're asking what power of 4 is equal to 16? Well, we know that 4 squared is 16. Okay. Now this says what power of 10 is equal to 1 over 10? Okay. Again, we have to think about our exponent rules. What type of exponents give us fractions? Well, we know that negative exponents give us fractions. So if we have a whole number base, but a fractional exponent, or a fractional number answer, we know that our exponent is going to be negative, okay? So how do we get from 10 to 1 over 10? This is the negative 1 power, okay? And our last example is real similar to that. So what power of 2 is going to be 1/4? Well, you know it's going to be negative. That's how we get the fraction, okay? And then how do we get from 2 to 4? Well, 2 squared is 4. Okay, so 2 to the negative 2 power is going to be 1 over 2 squared, or 1 over 4. Okay, so these questions are really going to require you to be super familiar with your exponents, especially negative exponents. Okay, all right. Let's move on to some more examples. Okay. We're still going to be using the definition of the logarithm. Okay. So just the way that this is written out, I know that it looks really confusing because there's just a lot going on, okay? So we're just going to start, as you always do with the order of operations, on the innermost part, and then we'll worry about everything else, okay? So I'm going to worry only about the very inside part, which is log base 5 of 125, okay? So we're saying what power of 5 gives me 125 as an answer? Okay, Well, 5 cubed is 125, so our answer here is going to be 3. Okay, so log base 5 of 125 is 3. And then I'm just going to keep everything else exactly the same. Okay, so I've evaluated this and I've written down my answer. Okay, now I'm going to evaluate the next part, which is log base 3 of 3. Okay, so what power of 3 is equal to 3? Well, 3 to the 1 power is 3. So when I evaluate this, I get my answer 1. And everything else stays the same. Okay. Then my last one is asking me what power of 10 is equal to 1. Okay, whenever we want to get 1 using an exponent, we know that the exponent is 0, right? 10 to the 0 power is 1. Okay, so we just start on the inside, write our answer, then we evaluate the next one and write our answer, and then we evaluate the last one and write our answer. Okay, let me give you guys one of these to try. Okay, so I want you guys to go ahead and try this one on your own, see what you get, and if you get stuck or once you get your answer, go ahead and unpause the video and we'll talk about the answer. Okay, all right, now that you've tried this yourself, the first question, again, we're ignoring the outside function and we're just saying, what is log base b of b? Okay, so what power of b gives me b as an answer, right? So what exponent of b gives me b as an answer? Well, we know that this is 1, so I'm going to evaluate this, and my answer that I get is 1. Okay, and now I'm going to look at this. So what power of b is equal to 1? Okay, well, again, anytime I want to get 1, I know that the exponent must be 0. Okay, all right. Now, the last thing that we're going to talk about, oh, I lied. We're going to do some examples with a calculator really quick just to make sure that you guys are comfortable using a calculator. So this is example 4. Okay, so we'll do one together so that you guys can see the calculator and how it's supposed to work. Ooh, if I had a calculator, that would be better. Okay, and then we'll go ahead and you guys can try one to make sure you know how to do it. Okay. Okay, so before we even do this problem, we really have to talk about an issue with notation. Okay, I'm still looking for my calculator, sorry. Okay, so what we're going to do, okay, we're going to take a little notation break. Okay, so log base 10 of x is called the common log. Okay, now before there were calculators and computers, people used this log all the time to do computations, and so they used it so much that it has its own special notation. Okay, so we can write log base 10 of x, or we can write just log of x. Okay, and this is what you'll see and why we're talking about it right now on your calculator is instead of saying log base 10, your calculator will just say log of x. Okay, so let's get back to our example. Okay, we're going to say log base 10 of 6, okay, and we're going to show this on the calculator. Okay, so what we're going to do is if you look at the buttons on the calculator, you can see that here's the one that says log, okay, And remember, this is the one that means log base 10. Okay, so I'm going to go ahead and hit that. That gives me log, and then I'm just going to put 6. Okay, and there's my answer. Okay, I got 0.778. Okay, if you're using your phone, you will need to put in the number first, so you would type 6, and then you would hit log. Okay, if you don't have a type of calculator that lets you do this, okay, you can buy one at the store. They're not very expensive. It doesn't have to be a fancy calculator like this one. I got one that does logs for about $5. Or you can always use programs on the computer that will allow you to compute the log. Okay. All right. So let me give you guys some examples of evaluating with the calculator to make sure you have it down. Okay. So I'll do log of 3.5. Okay, so go ahead, pause the video right now, and show your answers for these. Okay. All right. So once you've done this for yourself, or you've tried to do it, okay, let's look at what we would get here. Okay, so again, I'm hitting the button that says log first. That gives me the log screen, and then I'm just going to type in 3.5. Okay, so you can see that I'm getting my answer here, which is approximately 0.544. Okay, I can do the same thing for log of 12. Okay, so all of these are also log base 10, whether they say log base 10 or they just use the common log notation. Okay, so for this I got 1.079. Okay, now what happens when I do log of 0? So I'm going to hit log and put 0. Okay, and you can see that I got an error. Okay, now what that means is that this is undefined. Okay, so let's look at why that would be. Okay, so the question we're asking is, what power of 10 is equal to 0? Well, there's no power of 10 that's equal to 0. Okay, and that's why this is undefined, because there's no way to raise 10 to a power and get 0 as an answer. Now let's look at log of -2. Okay, so again, I'm going to hit log, put -2. Okay, and again, I get an error. So this is also undefined. Okay, now let's look at why that might be. Okay, so I'm saying 10 to what power equals -2. Okay, well, there's no power of 10 that's going to be a negative number. You can't get a negative number from an exponent of a positive number, right? Any power at all, you're going to get a positive answer. And that's why this is undefined. This is not possible. Okay, so you'll see that the stuff you're allowed to plug in to log is only things that are positive numbers. Okay, so let's write that down. So okay, so log base b of x can only be evaluated for positive numbers. Now, if we write this in the language of functions, that would say that the domain of log base b of x is 0 to infinity. Okay, so these are saying the same thing, that you're only allowed to plug in positive numbers to the log. Okay. All right. So let's talk a little bit about the relationship between logs and exponentials. Okay, so we know that we can have something like this, and because it has a log in it, this is shockingly called log form, okay, which is short for logarithmic form. Okay. But there's another way to write this exact same information. Okay. So what does this mean? Okay, it means that if you raise b to the y power, you get x as an answer. Okay, so if you raise b to the y power, you get x as an answer. Okay, and because this has an exponent, this is called exponential form. Okay. All right. So let's do some examples of going back and forth between information that's in log form and information that's in exponential form. What number example am I on? 5. Perfect. Okay. So we're going to go ahead and rewrite in logarithmic form. Okay, so we're not solving anything, we're not simplifying anything, we're just changing from this form, the exponential form, into this form, the logarithmic form. Okay, so the base of the exponent is also going to be the base of the logarithm. So the base of our exponent here, 3, is going to become the base of our logarithm. Okay, we can see that the answer here is going to be the input for the log. So we're going to take our answer and have it as the input of our log. Okay, and our log answer is the exponent, right? The exponent becomes the answer. So we'll take our exponent, negative y, and it becomes the answer. Okay. And this is all you're meant to do. You're just changing from the exponential form into the log form. You don't need to do anything else. Okay, so let's look at another example of this. Okay, we're going to look at 2 more examples. Okay, so I want you guys to go ahead and pause the video now and write down your answers to these in log form, right? These are both given in exponential form. You rewrite them in log form. Okay, now that you have your own answers, let's look at these. So the base of the exponent is going to become the base of the log. So the base of our exponent is m, so the base of our log is m. Okay. The right side is going to become the input, so 3k minus 4, the whole thing. And then our exponent becomes our answer. Okay. So let's look at this one. The base of our log is going to be the base of our exponent, which is 8. Okay. The right side is going to become our input, 5t. Okay. And the exponent becomes the answer, 1/5. Okay. All right, so in our last example, we're going to go ahead and go the other way. So we're going to change, in that example, we changed from exponential to log form. And in this example, we're going to change from log form to exponential form. Okay. We'll do 1 together. Okay. So the base of our log becomes the base of our exponent. So our base here is 2, so that's going to become the base of our exponent. Okay. For a log, the exponent is the answer. So here's our exponent. Okay, and then this will be equal to the input 0.05. Okay. All right, let me give you a couple of these to try. Okay, so with this example in mind, go ahead and pause the video and give your answer to these two now. Okay, now that you've tried this on your own, let's talk about the part B, okay? So remember, when you don't see a base, that means that it's the common log and this is base 10, okay? So our base is going to be 10. The exponent is our answer, okay? And this becomes our output, 3x plus 1, okay? All right, so we're going to do the same thing over here. The base of the log becomes the base of our exponent, okay? The answer is the exponent, so here we have a fractional exponent, m over b, okay? And this becomes our answer, p, okay? All right, so I know that logarithms at the beginning can seem really unfamiliar and that they're difficult to get used to. So I encourage you guys to practice with these, go back and forth between log form and exponential form, look at some values of different logs with different bases, okay? And in the next video, we'll cover what we might use these for, okay? So I will see you guys soon.